Here's a common problem. You have a directory or a whole hierarchy of directories, and you want to know when something changes in those directories. A newly created file, a change to an existing file, something's been deleted, so on and so forth. In the Python world, there's a handy library called Watchdog for just such a job. You can do anything from simply log activity to take action based on specific events in the file system, and it works cross-platform. So let's take a look at an example. In this example, I have my code in main.py, and next to it is a directory, my stuff, that I'm going to be watching for changes. The way we set up Watchdog involves a few steps and a couple of different data structures. The first thing we need is to set up the observer, the thing that actually watches the file system and returns events based on it. Now we also need to set up a handler, something that can respond to those events generated by the observer. In my case, I'm using one of Watchdog's built-in classes, File System Event Handler, which I'm going to be subclassing and customizing. Now, my version of the handler has explicit handling for two kinds of events generated from the file system, creating files and modifying them. I'm not doing anything more than printing a note to the console for each of these events, but in theory we could trigger any number of other actions based on them. Now, to bring all this together, first we create an instance of the observer and an instance of the handler, and then we use the schedule method to set up where to look for events and what to dispatch the events to. This recursive argument, by the way, tells Watchdog to look in all the subdirectories of our target directory for events. So now comes the fun part. We'll start our observer, which runs in its own thread, independent of anything else going on in our program. And now, in our main thread, we're going to take input in a loop from the user. What you'll see happen is that file system events get observed and acted on even while the main thread of the program is blocked and waiting for input. So you can use the observer pretty much independent of anything else going on in your program. Let's run this and demonstrate. I'm going to create a new file in my stuff, and as you can see, when we do so, we have a message logged. If I open an existing file and make a change to it, that too is logged. And meanwhile, the main part of the program is still sitting and waiting for input. Now, granted, the printing to the console has kind of messed up what our inputs look like, but the point is that we have our file system events watched and acted on entirely independent of anything else going on, including events that are blocking the application's main thread. And so we can build on top of that to create other behaviors that do whatever it is that we need to do with the changes that are recorded to our file system. Now, this is only a fraction of the functionality in Watchdog, but the basic approach should be clear. You set up an observer for the directory you want to watch, and you set up a handler for the events generated by observing. And all this is done in a thread that's independent of your main program. So that's it for this episode. If you liked it, leave a comment below, and don't forget to follow Dev with Serdar and InfoWorld on Facebook, YouTube, and Infoworld.com.